So we are here at another learning factory at the addlab at the TU Graz, and I'm talking to Christoph. Christoph, can you introduce you a little bit?
Of course. So my name is Prof. Sommitsch. I'm head of Institute of Material Science, Joining and Forming at our Faculty of Mechanical Engineering and Economic Science. And in the years of 2012 to 2015, when I was in a faculty, we started many initiatives in the area of smart production. So you remember at that time, of course, all the topics of Industry 4.0 popped up, and it was very important to establish activities in this field at our university. So also together with the rectorate, we made it a special project, smart production at TU Graz. And you remember, of course, there was a first learning factory. It was at your institute, the learning factory. And then also you established a makerspace. And in parallel to this, we applied for an endowed professorship for automotive production in batch size 1 production, or batch size 1 parts. And we succeeded. And with that, it was our first point to start also the establishment of a physical smart factory. And this here is a fourth lab. This is the so-called addlab. So here we are focusing on metal-based additive manufacturing. We have many facilities in our faculty, especially in those two institutes, production engineering and our materials institute. So we are dealing with both wire and powder-based additive manufacturing. And here physically in this lab, we have two powder-based selective laser devices. And yeah, here one is running, just running now.
Perfect.
So there is an active job here.
Maybe we can have a look at this running machine. So
And our university assistant Siegfried here can give us some comments about that maybe.
So Siegfried, what can we see here?
So this is a SLM machine, or basically a laser beam powder bed fusion device. It works as following. So you have a building plate, and on this building plate, each turn, a powder layer is distributed. And as you can see in here, you have a structure in the machine, and this structure is followed by the laser. And the material in here is molten by the laser, and so the whole structure is built up layer by layer. And as you can see in here, we have a parameter study now running at the moment, which we do a lot of the institute with different materials. This material, for example, is neodymium iron boron, a magnetic material which is used in sensor applications, in this case in cooperation with AVL. But we also do other different materials like shape memory alloys, stainless steels, structural materials, and the advantage of this technique is that you can have very high resolution parts out from this machine. And if you want, I can show you a few examples of these high resolution parts.
So let's see.
So these are parts we already have printed. I can take a few out if you want to have a closer look. For example, yes, you can build these very fine structures which are otherwise not achievable by other techniques. You can build it in large, like this. So you can have an outer solid layer, and inside there is a very fine structured, a fine structure, which can be designed by topological optimization. But you can also have, as I said, the resolution of this technique is very high, so you can go down to very small structures. And it can maybe not be seen in the camera, but inside this tower there's also a stair built by the technique.
This is amazing. So Christoph, unbelievable what you can do with this machine. Are there also other machines you operate in this lab?
So in this lab, basically, we have two devices. The first one you already saw here, so this is a smaller one with a smaller working space. So we are focusing on materials development here with magnetic materials as well as, for example, titanium alloys. If we can go here, we see a larger device. So this is from SLM Solutions, so with a larger working space. And here we focus more on larger parts and also on topology optimization. Here jobs are running especially for stainless steels and also aluminum alloys. So those two together, devices together, so with those two devices we can achieve very good progress. In addition, for example, this year we are also going in the direction of plasma-based additive manufacturing. So we will install a new device where we can both come from the wire and the powder-based material. So also we have other printers for fiber-reinforced polymers, not only in this lab, also in your lab, in the makerspace. And also the joining of those polymers together with additive manufactured metals is a very strong focus now, going for lightweight design and also aviation materials.
Perfect. Lots of new technologies at our university. Thank you, Christoph, for your time.
You're welcome.